In this video, we're going to be taking a look at our first lab project in CIS 300, as well as our first look into version control or source control. You may have used some version of source control before. Probably the most widely used version of source control is actually cloud-based services like OneDrive or Dropbox. Source control is basically just a system for managing files, and in this case, code. Or you can include that in other documents like Word and PowerPoint and other things. But specifically, our method of version control that we'll be using, or source control that we'll be using, is Git. Git is a highly specialized version control or source control system designed specifically for code. If you've ever developed any projects and actually uploaded Python code, C# code, or Java code to your OneDrive or Dropbox, it doesn't necessarily take it very well, especially when you have conflicts between versions. Most of the time, they're just blindly overwritten. And so they don't really work too well for the kinds of development processes or cycles that we actually use when we're programming. In this class, Git will be used for pretty much everything that we'll be doing, including labs and homework. All of your projects, labs, and assignments will be uploaded through GitHub, and that link that you get through GitHub will be uploaded through Canvas. No files will ever actually be directly uploaded through Canvas, but we'll talk about that here in just a little bit. Source control is very useful primarily for backing up things, keeping track of things, changes, among others. And this is primarily the reason why we use Git, because it does allow us to keep track of a lot of different things as far as code goes. One of the primary reasons why we use source control for 300, for one, it is used heavily in industry. And so once you actually finish your degree here, pretty much all of your coding will be done in some type of source control, whether it be Git or some other form. For our class, it also allows you to have multiple different saves of your code, so you can go back and forth between different versions, and you can also bring your code from machine to machine without ever having to use a cloud save like OneDrive or a flash drive. So what the heck is Git? Well, Git is officially a distributed version control system, or DVCS. Git operates primarily locally on your machine, so you will have versions of your project or files kept locally on your machine, although this could actually be spread across multiple machines. It doesn't just have to be on a single computer. Apart from your local system, a remote version is also kept. This is usually on things like GitHub, Bitbucket. You could even also have your own Git server apart from GitHub. Your local repository, or will also be referred to as your repo, contains a hidden folder that's called .git. If you don't have hidden folders enabled on your machine or shown on your machine, you should do so, because this will allow you to actually go in and configure Git manually if you need to happen to fix your repository, or if you just like to see how the Git structure is actually organized. But this folder is where Git maintains and tracks all of the different changes made to the current version that you're actually tracking. From time to time, you'll want to actually save your changes. Saving your changes is called committing in Git. These commits are only local though, so committing a change isn't necessarily going to update your remote repository on the server that you're actually maintaining all your copies. Committing does make these changes somewhat permanent as part of the local repository on your machine. Now, say somewhat permanent because these commits can be undone, but for this class, most of the time you won't really ever find too much of a need to undo these commits. But if you ever do so, please ask and I can help guide you through that process. But after a commit has been made, one commit or multiple commits, you can push all of those committed changes to the remote server. Push will actually cause all of these changes to be uploaded to the server that's maintaining the remote copy. Now, if there is an actual conflict with the remote version, so let's say you made a change on your local copy, but that copy conflicts with something on the remote one, which isn't an obvious overwrite. Now, this is one of the benefits that Git has over using something like OneDrive. It will actually flag these conflicts for you to manually pick what Git actually does. So these are commonly referred to as merge conflicts. So you can pick which version you want to actually keep for that change, or if you want to override it entirely. There are a lot of tools that can help you with this merging process. For most things that we do in 300, you shouldn't encounter too many merge conflicts, but to help reduce the number of merge conflicts that you may actually encounter, you should commit and push often. And before you actually leave your computer or leave a sitting when you're programming, make sure you do commit and push, because when you come back, or if you switch to a different computer, that will help reduce the number of conflicts that you may encounter. But let's take a look at a few more things on Git. Git can be used via command line or through other programs. For example, Visual Studio, or many other programs that actually have or apply a GUI element on top of Git. A lot of the commands that we'll be using in Git are primarily clone, which will completely copy a remote repository, commit, which we've already talked about, as well as push, and we've also talked about that. Pushing commit saves your local changes to your local repository, and push will upload all local commits to the remote server. Another common command that you may actually find yourself using is pull. Now, once you have cloned a repository, committed and pushed, or any combination of those, and you've come back, but let's say there are commits on the remote server that are not on your local machine. Let's say you've moved from your desktop to your laptop. You'll want to pull those changes from the remote server to your local repository. That will basically act as a download feature. Fetch will also is very similar, but it will be refreshing your local branches. Fetch is a little bit more of an advanced command that we won't really be using in 300. Likewise as merge, branch, and many more other commands associated with Git. It's actually a pretty complex system, but it's pretty easy to get the hang of once you've started using it. A lot of these more advanced commands won't be used in 300, but will be used in later classes like CIS 400 and 501. But if you find yourself needing to use some of these more complex commands, please reach out and ask, and I'll help guide you through this process. In class, we will be using Git, like I mentioned, for labs and assignments. For each assignment, as well as lab, you will be given a URL that acts as a starter URL or a starter code. This is in GitHub Classroom. This GitHub Classroom URL will actually cause your repository or the starting repository to be cloned underneath your own account in GitHub. This cloned repository will contain all of the code that you need to start the corresponding lab or assignment. Now, sometimes this will be an entirely new repository that you haven't seen before. Sometimes it will actually include some code that you've completed already in a previous lab. But it kind of depends on which lab we're actually on and what that starter code actually looks like. After the starter repository has been cloned in GitHub, you will then clone this repository onto your local machine. Usually we'll just do this within Visual Studio, but you can also do this through the command line. Once you have cloned this repository, you will work within that local repository, commit anything that you need to. All of these files will then be uploaded to GitHub. Folders, files, and other things that are not associated with your lab or programming assignment should not reside in this local repository folder, because these would be unnecessary additions to your homework submission. All labs and assignments will be submitted via Git. So all of your local changes, or all of your changes that you've made through your code, should be submitted or should be committed to your local repository. Once all of your commits have been done, make sure you push those changes to GitHub. Now, you can make more than one push to a repository, and this is expected, especially as you gain more knowledge on Git, and especially with some of the larger projects like homework. You'll have multiple commits and multiple pushes. Once you have pushed your final commit, you will submit the URL that is associated with that corresponding commit to Canvas. Now, this URL will contain an actual fingerprint of that commit. It's usually a 40-digit hex hash code, but that acts as an official signature that you have actually committed to this project, and will also let me and the TAs know which commit that we need to actually grade. So note that we will not grade any commits that are after or before the commit you actually submit in Canvas. Make sure you submit a URL or the URL that has this 40-digit hexadecimal code. Now, as I mentioned, most of the Git work that we'll actually be doing is primarily through Visual Studio's Git implementation. This is pretty much enough for what we'll actually be doing for CIS 300, but some of that work could be done through the command line if you so choose. And sometimes I'd actually encourage you to try using Git through the command line a few times at least, just to get used to it, because this is going to primarily be what you'll be doing later in classes like CIS 400 and when you get into the workforce. You'll need to be very familiar with Git command line tool. But the general process that we'll actually follow for doing Git in the command line looks like this. So you'll primarily add all of the local changes that you would like to. So git add star will add all the changes in your local repository. Now, you don't have to use star. You can add specific changes if you want to, not others. So that works out pretty well. Git commit, so that's the commit command, is to save all of your changes locally to your local repository. Usually with commit, you'll always actually add a message associated with that commit. I would encourage you to make these commit messages as descriptive as you possibly can, specifically about homework assignments, but this kind of acts as a map for you, and as well as a map for us to kind of track your progress. But once you've committed everything that you would like, you can push that to the remote repository. And again, you can push one or multiple commits. It doesn't matter how many you actually end up pushing to a remote repository, but it's not abnormal to have thousands of commits for a project that is even only 1,000 or 2 lines of code. So let's take a look at what these commits actually look like within GitHub. So here is just the actual starter code for Lab 1. But after you've committed and pushed to your remote repository, you can navigate to that underneath your GitHub account. Once you get there, the easiest way to find the specific commit you would like to submit into Canvas is right here. So if you click this little link here, it says commit. So in my case, it just says 1 commit, but depending on however many commits you have, that number will change, of course. But click that, and you'll come to a page that looks something like this. Now, all of your commits that you have pushed to your repository will show up here. And then the URL that you actually would like to submit is not this one. Okay, so if you click on one of the commits, it'll actually show you all of the changes that were committed and pushed as part of that commit. This is not the one that I would like. The actual commit that I would like you to submit, or the link that I would like you to submit, is actually this one right here. So if you right click this little less than greater than button and just copy link location, that is the URL that you would like to have to submit to Canvas. Now, if you click on that, you'll see that this is an actual specific commit. So if I show you my browser page here and highlight here, this is the actual commit the hex code that I was referring to in the video. So this is a 40-digit hex code that we will be using to grade. So make sure that this hex code is part of your URL. So generally speaking, the format of the URL will be, of course, github.com. This is the user or major repository that this repository belongs to. In this case, yours won't be KSU CIS 300 master. This will be your username in GitHub. And then this is the name of the repository. And then /tree And then after tree, this will be the 40-digit hex code for the commit that you would like to submit. And from this page, you or I or the TA can also browse the code of that specific commit.